Hi again. Today is going to be the last lecture of the React series, and we're going to talk about testing, how to do it, what is it in general, why do we test stuff and stuff like that, and we'll talk a little bit about client-side rendering and server-side rendering. What is that? Again, why do we need it? How does it differ and stuff like that. So, when we start building our application, we usually at some point start thinking about testing things, because not only we want to check how our application works every time, like during the development, but we want also ensure that some things that we cannot test by hand or would be complicated to test by hand would be tested and checked. So actually, there are two approaches in development. Some people debate which one is better. When we write tests before, let's go on this side to do not confuse you. When we write tests before starting development of the application, and when we write tests during or after we wrote the application or a component. So TDD or test first, test-driven development, currently hyped up in the community. Everyone going with the test, not everyone, but a lot of developers like to brag how cool it is to test-driven development. When you when you want to create a feature, you first describe how it should work with tests. So, for example, if you write some function, you describe what arguments this function will get and what output would it give after it complete with tests. So when you write your function or feature or even the whole application, you run tests and you kind of check if everything that you developed went right. But it might be hard to think about your application or feature starting from testing, because it might be complicated. Like, how can I know what will happen in my application before I develop it, right? Maybe I'll go with some other path. So you kind of need to think in advance with this approach. That's why for me personally and for a lot of like hands-on developers that I know, writing test after you wrote the feature is much more simple. You kind of already have an idea of the whole architecture of your feature or function. You know what you expect from it already. You kind of ran it a few times and tested by hand, so it's much easier to write tests this way. So when we talk about tests in general, term testing pyramid comes around a lot of times, and talking about testing pyramid, we have usually 3 or sometimes more layers, but 3 is a generic one. So kind of this is the simplest version of this pyramid. So it represents different types of tests in your application, starting from unit tests, going to integration tests, and finishing with end-to-end tests. This feature this pyramid represent amount of tests in your application by type of the test. So in your application, you should have the biggest amount of unit tests, a bit less integration test, and much less end-to-end tests. So the question might rise, why? How this test is different from each other, and why we have more of one than another. So unit test is a test for specific one single unit of your application, which comes from the name of the test. The unit might be a component if we talk about React application, or in a more simple way, it's just a function. So basically unit test, you can think about unit test as test that will test one single function. They're simple to write because we're kind of just go into the little simple things in our application. We do not test anything in how everything works. In general, we just test one simple component, how it works, how how it renders, or how some simple util function works. Maybe like the one that I don't know, sums something or multiplies something, stuff like that. With unit tests, you usually mock a lot of stuff. So if, for example, in your component, you import something, you use some libraries that comes outside, maybe some NPM or your custom libraries. Maybe it's some component that you use inside another component. That totally might happen when we talk about React application. Maybe you use some function inside another function and you want to test it. You will mock it. You will mock the result and output of it, because in unit test you need to think only about this particular unit in general, and not about the whole picture in general. So you do not care how the inputted stuff works. You only care about your particular function. So that's how you should think about that's how you should think writing unit tests. Go into integration tests. Again, this comes from the name of the test. You check how things work together. Usually, this is about checking how your, for example, API, the API that you wrote works with database, for example. If we talk about React, integration test can check how your application works all together, the big component, big page, for example, or if you have some backend calls, you might check how this kind of things works with your components and stuff like that. So, but most of the time, yeah, this is with integration test we check some different third parties, database and stuff like that in our application. End-to-end tests are more about business logic of your application. So user clicks on some button and some model window appears, and then he fills some fields in the model, clicks submit, and goes to the next page. This is what integration end-to-end test will describe. Yep. So with end-to-end tests, we usually test user flow, for example, starting from the first appearance user on the page and finishing with some result. For example, if we talk about some e-commerce stuff like online shops, if we would write end-to-end test, we would start, for example, on the home page of some shop and end up on the order confirmation page when user already ordered something, and this would end-to-end would test. So as you can see, to write end-to-end tests, you need to understand the business logic. You need to understand how user would behave. You need to write a lot of things to cover all these cases. So that's why running end-to-end test, writing end-to-end test is hard. But also you need to run some sort of emulator, like in Chrome, to emulate user behavior on your application. It takes a lot of machine machine energy, let's say, or capacity on some sort of server, or if we talk about running it somewhere or on your local machine, it usually runs much slower than unit on integration tests. So it's also expensive from side of time as well as money. As if we talk about something in production, we need and we want to run this test somewhere, not locally on some sort of server, probably we need to pay for that server, and time is money, and then takes a lot of time. So that's why we try to keep as less as possible amount of end-to-end tests as much as we can unit test, because they simple, fast, and cover a lot of things. So this is briefly about testing types and stuff like that. So today we're going to be talking only about unit tests, and in your home task you also would need to write only unit tests. So what you can use to do this? There are a few Npm packages that I can recommend. So in general, we use any of this from these three libraries for testing in general, writing unit tests. So Jest, Chai, or Mocha. Jest is most popular one, so I would recommend going with this one. And in addition to that, for testing React components in particular, you would need to choose something like React Testing Library or Enzyme in order to get this nice helping hand from perspective of rendering component, getting some props, passing stuff and stuff like that, which is specific for React. So yeah. So when I've been describing a unit test, I already touched a few of the rules which we kind of need to follow when we write unit tests. So the first one would be that we should avoid testing internals. So again, if we have some dependencies inside our function from the outside world, or like outside libraries or outside function that we use inside of it, we have to mock them. Because we do not care about how they work, we will probably test them separately. Or if we talk about some libraries that we download from npm, they've been already tested. It's not our concern to test them. We just assume that they work as we want them to work. So we test only our side, this and here and there. Sorry, here and now. The second one, we have to the test should be deterministic. So same as we go with writing React component, we use deterministic approach, writing our test, our component, same with test, we should go deterministic. So we should say, like, this is the prop that I would pass, and this is the result that I expect. No if or else. This is just how it should be, how it should go. I'll show you a bit later, maybe if it's a bit more of a vague explanation. The third one, we should avoid access expectations in tests. So when we write tests, there are we might end up with a false true result, or false result, or always true result, or always false result. So this is this rule is about this situation. So you should be really smart about how you test stuff and why you test this. So if you write 3 tests that test kind of the same thing about your function, but just different variants, you don't you should get rid of the 2 excessive tests. You should end up with 1. So just not to run things. Don't create situation when you write test just for sake of writing it. And you also should be smart about the results of your test. So false true and false result might occur if if you use input in your function that won't happen, for example, or if you again wrote test just for sake of writing tests. So be smart about it, and yeah, avoid testing things that are obvious. Don't strive for 100% code coverage. So in general, there are tools to check code coverage of your application, and they go and check, for example, if certain string have been covered in test, or if the certain branch of if else has been covered in your test. Stuff like that. These tools are built in, at least in Jest for sure. You can run certain command and boom, it will show you how many things has been covered in your test. So while you shouldn't go for 100% code coverage, this sounds a little counterintuitive, but usually in development we go for about 80% code coverage, just because there is a kind of rule that 80% of result, you'll get 80% of result just giving 20% of your effort, and to cover next 20% of the result, you need to spend 80% of the effort. That's why it just doesn't pay off. Usually covering just 80% works fine. So like that. That's the reason. So you don't have to cover all little nitty-gritty things in your application or function. Usually just be good and have will do. Avoid snapshot testing unless you're testing very short output. This is here it's really important to understand this correctly. So when a snapshot is just kind of print of the of some object in the specific in the specific time with a specific input. For example, if you have function that returns some sort of an object or JSON, you can create a snapshot of this JSON for a specific situations with a specific argument that you pass in this function, and compare the snapshots every single time you run the test. Same thing we use in React when we test component render, the component render. So we create a snapshot of the component with a specific props or specific handlers or a specific lifecycle happened, and every single time test runs, it will compare to the snapshot you created. But if you want to go with this rule, you should avoid testing big giant component like pages or a big sort of widgets or stuff like that. Because if you have a lot of lines of component like divs and spans and different kinds of elements and data and different classes, there is no way you can be 100% sure that everything rendered as you expected. So it is much easier to check your output when the component is smaller. So when you run the test first time, your snapshot test first time, it would create this kind of snapshot and save it in somewhere near your test. So you need to check it by hand, by eyes, let's say. you get to check it by yourself. So you're checking that it's rendered, that it's saved as you intended. And then next, every single time you run this test again, your jest or whatever you use will compare the result it get now with the result you saved. So the saved result should be correct. And that's why it is better to do snapshot testing with components that are small. But libraries like React testing library or Enzyme allow you to do shallow rendering. So you kind of render only this particular component and do not render internals of the component, kind of just names of the children and stuff like that. So that's how you can test bigger components without creating like thousands of lines of HTML. It will just show you children component as a React component, like JSX, and stop there. So that might be a lifesaver for this thing. It's also kind of same thing as was said here in the first rule. And the last one, don't rely on implementation details writing tests. So always when you write tests, you should not calculate something. So your tests should be really, really simple. Again, deterministic. You create some sort of structure or object or something, like mock your attributes, your pass this attribute in the function that you want to test, and result of this function shouldn't be calculated. You should not copy your implementation in the test, calculate it, and put it in the result. This just eliminate any benefits from testing. So kind of that's why your test should be like mocks of the result, like created in advance data that you will pass in your function, call of your function, and then check of the result of the call of the function with the again created in advance object or something of the result of the function. Yeah, let's go with the question now. Maybe something was too complicated, or everything is fine and we can go further. Okay, let's go then next. So there are a few methods that you can use in the Enzyme library at least to render your component. The first one is mount. It renders the whole DOM tree and gives you the query API to access DOM elements inside this tree, simulate elements, and read text content. Yeah, I prefer this method most of the time to render my components, though it is helpful if you need to do something with your components, and it's again helpful if you have class components. Render a simple one returns a string with render HTML code useful for snapshot testing, similar to render to string. Yeah, we don't know about this yet. Yeah, it's useful when you need the test HTML output. Again, similar when we need to test snapshots. And most of your smaller components would use this one. And shallow renders only the component itself without its children. This method would be yeah, that's not true. This function will be used whenever you need to test some components that have children. coming from here, just not to test again children itself, to stay deterministic. So now we're gonna go through different best practices that I will recommend you to apply when you write tests. So when we test something that is rendered to the DOM, if we talk about React or a simple application, some other frameworks, we might face with a leakage when we pop up every component in the DOM, we create a giant structure, and do nothing with it. So we kind of keep components that we already tested still in the DOM without cleaning them. So in order to prevent this thing, you can create in your tests, you can use before each and after each function. They would be run before every single test and after every single test accordingly, where you can clean your document body. Again, this is useful if you do not use stuff like React Testing Library or Enzyme. In them, this sort of thing's already implemented, so you don't need to worry about this, but it's nice to know that this might happen. Components render should be wrapped in act function. Again, this is for situation if you decide not to use Enzyme or testing library. That would also create, make sure you don't have leakage stuff in your application, in your testing suite. So, yep. Okay, yeah. Let's look at this example more closer. So here, you can see a nice example of basic testing. Basic single test. It starts with the function it. If we talk about again just, it starts with the function it, which has two arguments usually. The first one is the name of the test. The second one is a function that would be called on this test. So inside of it, usually we do something and end this function with the expression of calling function expect. It will test, you put inside as an argument something that you want to test. This is a result of some call of this function. Here, yeah, act will result with a container. I just didn't finish writing it for some reason. So act will result with a container. This was the result of the function that we wanted to check. Here is render. So we're rendering our component. We checked the text content of rendered HTML, and we expected this thing to be something. So after we called expect function, we will end up with a class, let's say, that has a lot of pre-added functions to informant to be. So kind of to be something, or if we expect something not to be something, we will add dot not dot to be something, or to be truly, for example, and then we don't need to pass anything in the brackets, or to be null if we expect the result of the call of the function to be null, stuff like that. If you use something like the code after you write this dot, it will tell you a bunch of different things, a bunch of different methods that you might use, so you don't need to memorize them. After some time, that just come. Sorry, 1 second. Yeah, here again. So this is the example of how you would write a single test in, right, if you use something like Jest. So you see everything is quite understandable and looks like a basic human language in this sort of way. So it shouldn't be a very complicated thing to do. So the next best practice is mocking. So we have to mock all data that we fetch or we get in our function or stuff like that. So here's an example of what we would do if, for example, in the function that we've been that we test, we would use something like fetch. So we create some mock. Here it's fake user. We use function just.spy on to replace result of call of the function of this object with something we want to. So kind of just spy on will create spy on the object, and every single time this method of this object would be called, it would be replaced with something else, or you can just kind of put it this way, a listener to check if the function you're listening to has been called at all. So this might be useful for checking for event handlers and stuff like that. We'll see this a bit further. So this is the way you would mock the result of the call of the function fetch. So here you can see how we go with a sort of deterministic way. For this specific test, I expect that fetch would resolve promise with the result fake user only for this specific test. I do not write any if or else or stuff like that. Everything kind of goes straight away. You kind of configuring the certain state of your function for your world for this meta. Yeah, so as inside of this component, some asynchronous action has been called, fetch. We will call our act function with await and then just go with expect as here with container. Again, after we finish with our test in we have to restore fetch because when we do stuff like this, it would be set it up globally for the file we're working in. So in order to other tests to work properly, we have to kind of clean our palette, as was here with the cleaning DOM. Here we're just restoring the proper work of method fetch, maybe for future to mock it again and stuff like that. All external components should be mocked. Again, simple as that. With unit tests, we test only this particular component. If you work with enzyme, you can just use function shallow and don't worry about it. If you go with testing library, you have to do this all the time. When you test component with children, you have to mock it with some predictable output that you want it to be in. Just as that, maybe with a string, maybe as here with some sort of a simpler component, because you don't really care how this particular child component would look, and you want it to always be simple and the same one, not to influence the result of your parent component, how it looks like. Container with your component must be attached to document so events work correctly. This is for testing some sort of event. For example, if you have some action added on the click on the button, this is what you should do. Just so you know. Because yeah, events are originally part of the browser API. That's why you cannot just work with an object from React and assume the events would work. You have to, this component should be part of the document. Dispatch real DOM events on DOM elements and then asserting on the result. So this is how you would test some events on your component. So you kind of rendered here, you mocking function that would be called on this event. Here it's how you would use it. So just again provide this function for you. We usually use this for just to work properly. We render our component with the handler that we would put on our click event. We oh yeah, here container, sorry. Told you the wrong thing before about act. Yeah, here's container, sorry. Yep, so we get our container with our component, then we create, we dispatch event on a click on our button. Here, it probably should come from the container. The button would be an event that you would get. Again, render or more of a mount to allow you to work with the internals of the component as it was, like if it was a real DOM element. So you can kind of find the child, attach some event on this child, not attach event, dispatch event on this child. Here to click, we're kind of emulating inside of the just situation how user would have clicked here. But if you remember, when we've been testing end-to-end test, we would have checked how business logic works. So a user clicks on a button and some sort of a model opens. Here we would just check if the handler that we attach on this button calls. We don't care about the real logic behind it. We go directly on the kind of code logic. So here you can see another function that can be used here for checking if the function has been called. So here we created this function ahead, so we kind of can spy on it and see if it was called or never has been called. And we expect this function to have been called one time. There is another function just to have been called without the number. So if we don't care how many times it has been called, we can do this. But specifying a specific number would make your test better and more specific in this sort of way to prevent, again, false true result when for some reason this function has been called 2 times. So in your situation, the test that won't specify the numbers of times would be false true, because in particular in the scope of the test you wrote, yes, it's true, this function has been called, but it's false true because your logic specify this function have to be called only one time. So this is a nice example of false true result. Don't test inner functions of the component. Again, same as with don't test internal of the function, don't tell children of the function. Here you don't need to, if you're testing some function, you don't test inner functions of the component itself. For example, if it's some sort of class component, for example, or a smart functional component with some hooks, you don't want to test how the component did mount worked. You don't want to check how um, different lifecycle hooks work, how use effect work. In this, if you have this thought about testing these functions, in reality, you need to test, use snapshot test, and you need to mount this component and check how this was mounted. You need to update props of this component, and again, test how this was rendered. You do not test inner functions of the component. If you have some functions that can operate without relation to any inner props or state of the component, these functions should be outside of the component. They are considered util functions. They can be separated from the component without any harm. They would be tested separately as a simple function. So you kind of just check them. Again, for example, you have some math function that would add one number to another. This function isn't connected to some specific component. It can work on its own. Maybe it even can be used in separate components. So you kind of put it away and test it separately. Instead of snapshotting the whole component, output snapshot a part you're testing. This is not applicable for a lot of cases. This kind of breaks a little bit rule about this might look like going with this rule, but again, you kind of writing, you creating access tests that you might have avoided writing just a whole snapshot for the component and covering a lot of cases at once. But again, you want to be smart about writing big tests like this without testing specific parts. You want to understand that when you write this snapshot, you will cover 1, 2, 3, 4 cases. So you don't need to write like 5 separate tests checking every single text content in your component. So this this sort of code isn't good enough. So this is not like good. This is fine. So the better would be to just check snapshot of the whole application, whole component. So here you're kind of testing just a child of the container. Not exactly clear what you want from here. And again, if you go with the shallow or with mocking children, children like components, you won't really have them, but if it's like a simple component, again, you might have this. So this test isn't clear from the kind of these lines what you're testing. Show out of or of choose error message, but you checking the whole component. Yeah, for the sake of checking this particular thing, you might go with the text content of this. But again, I would go with just checking snapshot of the whole container for this sort of thing. So this is it for the best practices. And so if we want to get to write some selector for certain element, there are also some good and bad cases for that. So you won't go with some name of selector of the component itself. We don't recommend that. Same with coupled styles, so like button, sign of button large. IDs in general are also bad, but sometimes they can be used, but it's really, really rare case. For a test, it's good to create some sort of test ID. So you kind of bound it to a specific purpose, because with the classes they might change. Yeah, we might create different style, we might create add new parent somewhere else, we replace it or move to a different place. So this kind of structure won't work here. This is a good way, I would say, to write selector for your components. You kind of create a separate instance of it for this and use get by test ID function for this sort of sake. Again, when you create data attribute, they're not visible to users. But again, yeah, it's additional implementation detail. So you kind of extending your code might be debatable, but in my opinion, this is the best one. Using some kind of specific attributes like alternative, role, and stuff like this might be a better solution than this. Again, it's not visible for users and already part of the API. We seldomly change something like this. Yeah, from the point of view of the creator of this not presentation, but article that I used it from, this is the best solution. This is visible for user part of the API, but again, I would not recommend using this, but because this kind of text going using selectors as a test node isn't really reliable, in my opinion. Again, creating data test IDs more of a stable way to go. So again, if you need to create some sort of selector, for example, in your rendered component, go for the child. And like here, when we're tested button, I would create some data ID on a button and use it to find it inside of this toggle to dispatch some event on it. So from this is more, in my opinion, best way to go. So yep. So to wrap it up, how can we test certain component? We test result of the component render. We use snapshots for it. We test result of toggling different events. Again, we might use snapshot for it if some UI renders changing, or we can catch event handlers and check if they have been called. And yeah, using the snapshot. So this more of a the first point of this is more about this approach when we check the internals, and the snapshots is more of a general way to go. Yeah, in your application, you're gonna work with the Redux, so you might ask, how can I test Redux in scope of this way? In scope of this, so you can go with the testing whether the correct action creator was called and also whether the right action was returned on call of this, on dispatching this action. You can test whether the reducer returned the new state after applying the action to the previous state. So you kind of test in reducer the function, and then you test your inside of your component action and action creator. But what I want you to consider again, when you test your component, which would have some access to the Redux, I would recommend going separately from Redux. So from your component, you would export something like connect, bracket, some map state to props and map dispatch to props, closing bracket, and again open bracket, name of your component, and close bracket. So you kind of exporting wrapped in connect component. So in addition to that, export your component separately from this file, or maybe move the wrapping your component in the Redux in a separate file in general. Maybe I show you. So you can test your component again separately without need to mock Redux, because this might be really painful. So you would test Redux separately from component and component separately from Redux. This, yeah. It was here. So what I meant when I talked about separating Redux from the component, movie card. Yeah, so here you can see I have component and I have container. So component, again, something really, something really dumb. Yeah, so something about UI itself. Container would be something smarter, something with some functions here, some, if you want, even separation of the lifecycle stuff and things like that. Yeah, we don't have Redux here, but you also can separate in this component stuff like Redux here. Yeah, it's another file here, but again, you don't have to do 3 different files. So this is how you would separate your Redux from your component. Kind of created already your component. This here you see how I added selector action, created my map dispatch and map state, added them to my connect. Boom, exporting this from the file that have everything connected to Redux. And then from my folder with component, I export not the component itself, but this enhanced component with the Redux. So then in tests, you can test component with UI separately. And if you need, test your map state, map dispatch separately. So a little bit of examples. This is how simple test of really simple snapshot. Oh my god. This is how snapshot test of really simple component would look like. So we're importing our component. We're importing some React in order for this thing to work. Importing some methods from enzyme. Or from React library, wherever you choose, they both great. I'm creating my test suite with describe. So this would be like collection of different tests connected to this method. Inside of this function, you can add before each and after each and before each statements if you want some sort of things to happen before every single test and after every single test. You also can add functions like before all and after all if you want to do anything after or before all of the tests. Again, might need it, might not, whatever you like. So here I created one single test to check snapshot of the footer. I mounted my component. Here it is. I expect this component to match my snapshot. Again, first run of this test would create snapshot, and every single test after that would just compare the snapshot to the one that was created the first time. This is the example of the more of a complicated component that has children. So here you can see that I used already shallow to render my component. So every child that is React component inside of this won't be rendered. It would look like just a JSX like this, basically. I pass here some props that I mocked before, and I again expect it to match my snapshot. Yeah, this is test of a function. Here it was, this example has been made in map state to props. You can test this way any util function, and you like this, just an example. So here I created my test here, the first test, expect function to return proper object from it. So I created the state here, some sort of a starting attribute, and I expect basically it to return current movie from it. Here, in the situation where when you test some sort of a util function, another object might appear like result, and you just put it here. Boom, everything works great. Yeah, an example of the event testing. So I'm creating again my test suite. I'm mocking my function that would be called on submit. I'm mocking some props for my component. Here I created my component just so, yeah, this is the nice example of how I can use before each. So in every single test, I need my component to be rendered. So not to avoid writing this component shallow blah 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 in every single test, I just do it before each and use it in every single test. That might be useful thing to do. So in first test, I expect it to match my snapshot. It's just a simple test of the snapshot testing. The second one, I expect handle submit function to be called at submit of my form. So in my component, I find form. You can use here again some data attributes to find components. So here, not really good approach has been used according to this table, as we can see. So I would recommend using this. We found our component, we simulated our submit. Again, this comes with enzyme. This won't work the same if you go with testing library. It would be more of a rough thing, like here when we use a browser API to dispatch event by hand. So here we simulate our submit, and we expect the function that we passed as prop just to have been called. Again, would recommend to use to specify how many times, even though it might be excessive. It would ensure that nothing went wrong in this case. Yeah, this is it about testing. Here I added a lot of useful links for you to go through to read about testing recipes again that I summarized here. Testing utilities, React testing libraries, enzyme, how Jest works with React, different kind of combinations of this stuff, and a lot of useful things. So I encourage you to go through this when you write your tests. Yep, and we'll sum up with talking about client-side rendering and server-side rendering. So client-side rendering, it's a more recent kind of rendering method that relies on JavaScript to execute on the client side on the browser via JavaScript framework. This is exactly what you would have now when you write your application. So kind of empty page comes to the client. When the page came and all of the nodes of the HTML that came are parsed, and it came to the execution of JavaScript, it executes React JavaScript, executes all our JS files with our components, add them on the page. So basically, our page being rendered on the way. So I'm just seeing if I can show you the example of how it would look. So you obviously know about inspecting mode. I'd better open Chrome. So you obviously know about expecting mode, but in Chrome you would have another thing. View page source. So basically you can see what the server sent to the browser before before JavaScript was executed. And with the client-side rendering, if you go here, you basically would see an empty page. You won't see all these elements. Your main tag would be basically empty, only with some links, some JavaScript and stuff like that. So probably nothing would be in your body. This is how, in a nutshell, React works. If we talk about server-side rendering, browser gets from the server already created page. So basically, some JavaScript has been called, or Java probably, has been called on your server side. Page has been built, and already built HTML has been sent from the server to the client. From the scratch, React cannot do that. Because we kind of call JavaScript directly in the client. This won't work this way, but yeah, there are tools that you can use to create server-side rendering with React, and it is Next.js. It's a library that you run on your Next Node.js, for example, server that would create this page for you. And when browser requests this page, it would be kind of pre-rendered for you. So yeah, this is a sort of a schema of how these two things work. So server sending response to the browser. Basically, we all start with just requesting our page. Server sending response to the browser. We're still loading. Browser downloads JS. We're still loading our page. Browser executes React. We're again still loading. Browser user won't see our page. All kind of components will just rendering appear, just jump, every page would go bamboozle. And only after all JavaScript has been executed, page would be viewable and interactable for our user. This is with client-side rendering. What happened with server-side rendering? We request our page, server sending ready to be rendered HTML response to the browser. So initially, server did all the things for us, but server is much more capable machine than the machine of the user. That's why it goes much faster. Probably even some pages has been stored already, like the one that doesn't change. So maybe it's even loaded them from somewhere. So server sending ready to be rendered HTML response to the browser, and right away page is already visible for the user. User already can scroll it, can see some information, read it, and it's amazing. User already see stuff. Because why it's amazing? Because statistically, user leaves page if it doesn't load after 5 or 3 seconds. So for the businesses, that's crucial. So browser renders the page now viewable, and browser downloads JS. Browser executes JS, some React, some why we need to execute React again. So here on this stage, we just got HTML. Yes, it was rendered by React, but on the server, our browser doesn't know yet that it is React, and React doesn't know about any components. So we kind of have to put React back on all of the components that has been rendered. Browser executes our React, hydrate, as we call it, our page, and page become interactable for the user. Again, this all sounds complicated. Next.js makes it easier for you. It's really not that hard as it sounds. So cool thing. Again, not again, but another thing that why server-side rendering is cooler than client-side rendering, and why like 99% of the cases we use server-side rendering, because you probably know that there are robots that go through your page from Google to indexate your page, to understand that it's not fraud or something like that, that there are no dangerous content for users, that Google really can show it. So when we use server client-side rendering, robots won't see anything. They cannot execute JavaScript. They would read just HTML that came to them, and for them, your page would be empty. They would not indexate it. They won't show it in the Google search. It would go down and bad for business. With server-side rendering, as we already show, the web crawlers created HTML. They already can indexate it, go through it, see the content and stuff like that. So this is another thing why we should use server-side rendering more. So yep, this is it for testing on server-side rendering in React. Maybe you have questions for me. Maybe about home task again. This would be your last chance to ask them. So you're free to go. Okay, no means no. Thank you guys for joining. Yeah, we're finishing our lectures about React, sorry. And yeah, I wish you all good luck with your home task, and bye bye.